Hello everyone. Today we are going to learn about data structures used for bankers algorithm. Learning outcome of this session are: at the end of this session, student will be able to describe data structure required for bankers algorithm. In last session we studied about deadlock avoidance algorithm using resource allocation graph. That resource allocation graph mechanism is useful for the system which has single instance of resource type. But whenever we have a system with multiple instance of resource type, then this resource allocation graph is not applicable. So this resource allocation graph is not applicable to a resource allocation system which has multiple instance of each resource type. Means each resources has a multiple instances. They don't have a single instance. For single instance resource type, then it's okay. Resource allocation graph is okay because we can immediately detect a cycle in that graph. But whenever we have a multiple instance of each resource type, then resource allocation graph is not applicable. So for this system, bankers algorithm is used. Now the name of the bankers algorithm is given by taking the concept from the bank. That concept is: bank never allocate its available cash in such a way that it could no longer satisfy the need of all its customer. Means what? Bank have to satisfy all its customer needs. So it cannot allocate the whole cash to the customers. And if it allocates the whole cash to the customer, and if new customer enters and ask for the amount, then that customer must be satisfied by the bank. So the care must be taken by the bank that it never allocate its available cash in such a way that it could not satisfy the need of all its customer. And this is done by bank by using the technique that bank ask each and every customer to keep minimum balance in the bank account. So whenever customer reaches to minimum balance, that customer cannot withdraw money from its account. Okay, and that means bank always have a cash available to it. Okay, and that same concept is applied in operating system to avoid deadlock. So bankers algorithm is one of the mechanism to avoid deadlock in the system. Now consider that we have a process P. So whenever that process P enters into the system, it must declare number of resources which are needed. That number of resources must always less than the total number of resources which are available. Okay. So whenever new process enters into the system, that process must declare the number of resources, and all need of that process P must be less than total number of resources which are available in the system. Now process P, it has given its need, then it requests some set of resources from its need. Okay, and it requests some set of resources, and then operating system has to determine whether the allocation of the resources which are requested by process P will leave the system in safe state or not. Okay, so if it first determines it, and if it finds that okay, after allocation of the resources system will be in safe state, then it will allocate the resources which are requested by that process to the process. But if no, then process has to wait till any other process releases enough resources. Now why process has to wait here? Why process has to wait here? Because if process don't wait, and if other resources are allocated to the process, whatever is requested by that process, then that process will get that resource, but other process again try to get the same resource. Okay, and here the system may enter into the deadlock state. So to keep a system as a deadlock free, it is better that process should wait till other process completes its execution and releases the resources for the current process. So, for this we require a data structure, that is number of processors, number of processes and number of resource types. Okay, total number of resource types. So, along with number of processes and along with total number of resources, we require different data structure which we are going to apply for Banker's algorithm. First is available matrix. Okay, what this available matrix is? It is nothing but number of available resources of each type. Means suppose you have 4 type of resources. Okay, then how many instances are there for that resource? That is nothing but the available. So, available of j equal to k means k instance of resource type rj are available. Means suppose your resource is pen drive and there are 5 instances of pen drive, then we can say that for available of j means pen drive equal to 5, k means 5. So, 5 instance of resource type pen drive are available. Then the next is max. It is an n by m matrix. N is what? Number of process. M is what? Number of resources. So, n by m matrix which define maximum need or maximum demand of each process. The max I comma j is equal to k means process pi may request at most k instance of resource type rj. That is the second data structure. Then next data structure is allocation. Allocation is again an n by m matrix. Okay, it is again 2 by 2 matrix. Max is also 2 by 2 matrix. Okay, allocation means it is a 2 by 2 matrix which defines number of resources of each type currently allocated to each process. Okay, how many number of resources currently allocated to each process. So, allocation of I comma j equal to k means process pi, I stands for process, j stands for resource, k stands for instance. So, allocation ij equal to k means process pi is currently allocated k instance of resource type rj. For example, we have resource pen drive with 5 instances and process P1. Suppose we have given 3 pen drive to process P1, then we can say that P1 have 3 instance of resource pen drive. That is what? Out of 5, 3 are allocated to process P1. That is the matrix allocation ij equal to k. Next matrix is need matrix. It is an n by m matrix which indicates the remaining resource need of each process. Now, suppose process P1 requires 4, but currently allocated only 3, then remaining need is what? 1. 1 is remaining need for process P1. Okay. So, need matrix shows that the need k more instance of the resource type rj. Okay. Remaining resource need of each process. So, need I comma j equal to k means process pi may need k more instance of resource type rj to complete its task. So, how this need is calculated? Need is calculated using max minus allocation. Max is what? Max is maximum need. Max is maximum need of that process. Okay. So, total need of the process. Allocation means what? Out of that total need, how many number of resources are allocated? Okay, that is allocation. So, total minus how many allocated gives need matrix. Okay, it gives need matrix. So, need is calculated as max minus allocation. Now, let us consider that suppose we have x and y vectors of length n. Okay, then x less than equal to y if and only if x of I is less than equal to y of I for all I from 1 to n. For example, if x is 1, 7, 3, 2 and y is 0, 3, 2, 1, then we can say that y is less than x. How y is less than x? This 0 is less than 1, 3 is less than 7, 2 is less than 3, 1 is less than 2. So we can say that y is less than y is less than x, or we can say x is greater than y. So in addition, y less than x if y is less than equal to x and y is not equal to x. Okay, so this is the condition. Now 1732 means what? This means we have total 4 resources, and among that 4 resources, x is nothing but one process who has allocated one resource of one instance of first resource, 7 instance of second resource, 3 instance of third resource, 2 instance of fourth resource. Similarly, 0, 3, 2, 1 are allocated to process y, and as all the numbers of this y are less than x, we can say that y is less than x, and y is less than x if and only if value of y is less than x and y is not equal to x. So if this is the case, then vector allocation matrix we studied, which shows allocation matrix shows how many number of resources are currently allocated to process pi. So allocation I will specify the resources currently allocated to process pi, and the need matrix specify the additional resource that process pi may still request to complete its task. So need means still that process wish to complete its task, and these are the number of resources which that process needs. Okay, so that is the need matrix. So this is what the data structures use for the Banker's algorithm, that is available matrix, allocation matrix, need matrix, max matrix. Okay, so these are different data structures which are used for the Banker's algorithm. In next session we are going to see the algorithms, that is safety algorithm and resource request algorithm used in Banker's algorithm. Thank you all of you. This is the reference and